Okay, welcome to Unit 1, Lesson 3. So this lesson's about estimation and percentage error. Our learning goals here are to be able to approximate and round numbers to a certain number of decimal places or significant figures, to make reasonable estimations, and to calculate the percentage error. So first, what we're going to start with is the idea of rounding. So on all IB exams, the protocol for rounding is that unless stated otherwise in the question, all of your answers should be either given exactly or given correct to three significant figures. So it's not always possible or practical to give an answer exactly. So it's really important to be able to round to three significant figures accurately. So in order to accomplish this, we need to know some rules about what counts as a significant figure. So when we're thinking about significant figures, most important rule is that all non-zero digits are significant. So if it's not a zero, definitely counts as being significant. The next rule is that zeros between non-zero digits are also significant. So the zeros in this example of 20,004 do count as significant figures. The next one, or the next two, are kind of related. Zeros to the left or preceding the first non-zero digit are not significant. So for example, the 0 prior to the 2, 3 in this example here are not significant. So you'd only start counting your significant figures when you reach the 2 and the 3. So those would only be two significant figures. The other end of that spectrum is actually kind of the opposite. So zeros after other digits and after a decimal point are significant. So it's really important that we recognize that, for example, the zeros here do contribute to the accuracy and precision of this value. So those zeros count. So basically, sometimes we call these this prior example leading zeros, which are not significant. We call these kind of trailing zeros. They are significant. And we call the other type sandwiched zeros. And those are also significant. So basically, everything is considered a significant figure except your leading zeros. So when you're rounding, it's really important you're aware of these rules in order to be accurate about what you're doing. So let's try some examples, and we'll keep these rules in mind for ourselves. So if we look at the first example, A here, all of these are asking us to round to three significant figures. This is the most common type of rounding you're going to do. So if we look at the first one, we want to use proper notation to indicate that we're rounding. So that's usually the squiggly equal sign, or you can also use the equal sign with the dot over. So 24.37, the 2 and the 4 are definitely significant. And we still need a third digit to be significant, but we have to be mindful of what that third digit is going to be. So in the original value, the third digit is 3, but it's followed by a 7. So that means we're going to round up the 3 to a 4, and that's going to be our rounded value, 24.4. The next one is interesting because it's a value that starts with 4 digits and no decimals. So when we're rounding this one, we have to think, okay, so we need the 1. These are sandwiched zeros, so they still are significant. So we're going to put a 0, but the 0 is followed by a 5. So again, general rounding rules apply. Since the 0 is followed by 5 or higher, we're going to round that 0 up to a 1. But we've exhausted our three significant figures here. So we have to use, for the final digit, something that is not considered significant. So we are going to use a 0 because it's not significant because there's no decimal place here. So this is still 3 sig figs, and we need that 0 there because it keeps us in the right sort of magnitude, around 1,000. If we look at the third example, we have 4 digits after the decimal. The 0 in front of the decimal is not considered significant, so we only start recording after the decimal. So the first sig fig is 2, then 9, and because our 8 is followed by a 1, that just stays as an 8. And then the last one, we still have the first 2 digits, 1 and 0, and the 4 is followed by a 1. So we're not going to round the 4, but we have no more significant figures. We're going to complete this rounding with just zeros. So again, we're in the right magnitude, 10,400, but we've rounded it down to 400 from 410. So those are some examples of rounding to 3 sig figs, and that's really important for all assessments that you're able to do that accurately. So the next major concept for this lesson is what we call accuracy and error. So there's a formula that allows us to calculate something called percentage error, which is basically comparing an estimate or an approximate value with an exact value. So the formula is here, and this will be given in your formula booklets so that you don't need to memorize it, but you do need to be able to interpret and apply it accurately. So there's some things we should draw attention to here. The first thing is these vertical bars in the formula, and those vertical bars represent something called absolute value. And when we're talking about absolute value, the value inside the bars, the vertical bars, is always or becomes positive. So it's really important that we recognize that the quantity or the final answer for percentage error can never be a negative number. It's always just a positive number. So some examples of absolute value. The absolute value of 5 is still 5. 5 started out positive, and we don't need to do anything. It stays positive. It's 5. But the absolute value of -3 is +3. So the application of these absolute value bars is what causes the value to become positive. So that's the concept of absolute value. Whatever is inside those bars becomes positive. So that's really important to remember when you're applying this formula. Other than that, you just apply it as it's written, follow order of operations, and remember that VA is approximate and VE is exact. And it does tell you that in the formula booklet as well, so just make sure you're reading carefully when you're doing it. So the last step is to just apply this in an example. And this example is quite nice because it ties in with the last lesson, which was scientific notation. So whenever you're doing a calculation or writing a solution, you should always start with the formula. So our percentage error is the absolute value of the approximate minus the exact divided by the exact. So you're basically finding the difference between the two values, divide that by the exact value, and then multiply the answer by 100%. And so your answer will be measured in percentage. So if we substitute in our values, our approximate is 2.2 times 10 to the 8. So we're going to substitute that in, and we're going to subtract our exact value, 2.998 times 10 to the 8, and we're going to divide that difference by the exact value again. So you're basically trying to figure out what percentage of the exact value are you off by, and then we multiply that by 100%. So when you do this on your calculator, you'll get the difference to be negative 7.98 times 10 to the 7, and we still have to divide that by 2.998 times 10 to the 8. Now, because we are taking the absolute value of this ratio here, even though it would normally be negative because I'm taking a negative number and dividing it by a positive number, the absolute value bars dictate that I now must make that positive. So even though on your calculator you'll get a negative answer, the bars mean you then make that a positive answer. So this becomes approximately 0.266 times 100%, which means our error to rounded to 3 significant figures is 26.6%. So it's really important to be able to apply this formula accurately, to know that your answer should always be positive, and to know that the units are percent. So hopefully now you feel comfortable rounding to 3 significant figures and using the percentage error formula.